Hey everybody, Mr. Piercy here, and what we're going to be looking at in this video is how you're going to actually be utilizing trig ratios with right triangles, how you identify what the ratios would be for sine, cosine, and tangent based off of what angle of reference that you're using is. You can use the trig ratios to identify a missing angle of a triangle. If you're asked to find an angle, you can also use them to find a missing side of a triangle if that's what you need to find. So hopefully what you have while you're watching this lesson is the handout that goes along with this, so you can kind of follow along and fill it in. Otherwise, you just need to copy this stuff down into your notes and use it separately as opposed to the foldable activity that this thing has. So in example 1, what we're asked to use is says find the trig ratio for an angle theta. So remember here, this symbol is a Greek letter, kind of like pi is a Greek letter called theta. That's not the only angle, or that's not the only symbol that we use. We often use alpha to represent an angle. We would use beta often to represent an angle. And this y-looking one here is gamma. Those are common Greek letters that are used to represent an angle that you're talking about. Theta happens to be the most common one, but those are not the only ones that you will see. So here, looking at the angle, theta is at angle A. So angle A is my angle of reference. So side BC, where the 12 is, this is the side opposite of it, and AC is the side adjacent to it, and AB, because it is across from the right angle, is always a hypotenuse. The hypotenuse will never be considered an opposite side or an adjacent side. Let me go ahead and write that down here so that way we can. Hypotenuse is never the hypotenuse is never going to be considered opposite or adjacent, because by definition the hypotenuse must be the largest side of a right triangle, and it is always going to be located across from the right angle. So while our angle of reference can change depending on what acute angle that we're looking at, the hypotenuse will never be anything other than the hypotenuse. Let me go ahead and put this here also. The right angle is never going to be your angle of reference. The only time that we're going to use an angle of reference in a right triangle with trigonometry, it will be an acute angle, one of the two acute angles that we see. So now that I've gone off on a little bit of a tangent here, let's come back to the example that we're looking at. Given the hypotenuse and a side, find the cosine of theta. Well, according to our abbreviations here, SOHCAHTOA, that means that cosine of an angle is equal to the adjacent side over the hypotenuse. So we need to know what is the adjacent side and what is the hypotenuse. And in this case, you can see in the figure, we know what the hypotenuse is. It's 4 radical 13. And we know what the opposite side is. It's 12. But we don't know what the adjacent side is. So when we fill these in here, the opposite side, that's 12 that was given to us. And the 4 radical 13 was given to us to be the hypotenuse. Now again, because we know two sides of a right triangle, we can use the Pythagorean theorem to figure out that the adjacent side in this case is 8. So we do have to do the Pythagorean theorem to find how long side AC is, and when we do, it'll be 8 units long. So here, I would say the cosine of theta is equal to the adjacent side, 8 over the hypotenuse, 4 radical 13. And in this case, we can simplify the ratio, and I can say the cosine of the angle is equal to, and it'll be 2 over radical 13. And of course, because we cannot leave, let me go ahead and clean this up here. Because we can't have a radical in the denominator of a fraction, we can go ahead and kind of rationalize that and say the cosine of the angle is equal to 2 radical 13 over 13. And that's what we would write as our ratio for the cosine of theta in this case. So let me go ahead and let's pick a different color here. And now let's look at the sine of theta. Well, according to our SOHCAHTOA acronym, sine of an angle is the equivalent to the ratio of the opposite side to the hypotenuse of a right triangle. Now, looking where my angle is on the triangle, theta is going to be used at angle B. So from angle B, segment AC, this is the side opposite of the angle. This is the side across from the right angle, so that's the hypotenuse. And BC actually is part of the angle, and it's next to it, so we say that's the adjacent side. So in this case, we know the side opposite and we know the side adjacent, so we can say that those are 5 and 12. And if we remember what our Pythagorean triples is, a 5, 12, 13 is one of the most common Pythagorean triples that we have, so I can use the Pythagorean triple to say that the hypotenuse in this case has to be 13 units long. So now we know the opposite side and we know the hypotenuse, so now I can say the sine of an angle is equal to the opposite side over the hypotenuse, which in this case would be 5 over 13. And we'll just leave it as a ratio just like that. So that's how we're looking at the first two to actually see, well, what would the ratio be? Now we would use, in this case, we would use those ratios to find the measurements of the angles. So let me just take this one step further, and let's go back to the original one. Let's go back to the first one. Go to red. So for instance, for the cosine, if I wanted to know actually what is the measurement of the angle, I would say it's the inverse cosine of 2 radical 13 over 13. Type that into your calculator like that, and you would be able to say that the angle is approximately equal to 56.3 degrees. And obviously, when you're typing these into your calculator, the mode of your calculator does need to be in degrees. Let's go ahead and look at this one here. So theta in this case, if I wanted to actually know what the measurement of angle B was, I would say the angle is equal to the inverse sine of the opposite side over the hypotenuse. And in this case, I would say that the angle is approximately 22.6 degrees. So again, make sure that you keep your angle or keep your calculator in degrees and not radians when you're doing these things. Otherwise, you'll get kind of weird answers. Just in case you're wondering, remember an angle can be measured in more than one, measurement or in more than one scale. Like inches and centimeters can both be used to measure a line segment. Well, degrees and radians are just different ways of measuring the same angle. In geometry, we don't really get too much into what a radian is. We kind of keep everything in degrees. So now let's take a look here at our second examples. Here they're giving us some information, And what it wants us to do, it says to sketch the figure, see what it would look like, and then find some of the missing information here. So this is just a generic right triangle. So I'm going to say this is angle A, B, and C. And so I'll make that one my right angle. So we know that angle B is 49 degrees, and we know that side B is 7. So side B will be across from angle B, so segment AC in this case would what we would look at as side B. So we know that information, so that's what we're going to start with. Okay, well we have to figure out what's all the rest of it. So here it says use the triangle sum theorem. That basically says, obviously, that the three interior angles of a triangle have a sum of 180 degrees. Or you could be more specific and say, well, the two acute angles of a right triangle have to be complementary. So that means that we can say the measurement of angle A is equal to 90 degrees minus the measurement of angle B. So I can say 90 minus 41 to equal, I'm sorry, not 41, 49 degrees. So I can say that angle A is 51 degrees. So now it says use a trig ratio to find a missing side. Okay, so we can find either the hypotenuse or we can find the side adjacent to angle B. So I'm going to go ahead and label these things. Here, this is my hypotenuse. This is my side adjacent to the angle. This is the side opposite of the angle. So we know that the side opposite of the angle is 7, and we need to find either side A, which would be segment BC, or we need to find side C, which would be the hypotenuse of the triangle. It doesn't really make a difference which one we want to do. So I'm going to go ahead and say, let's find the adjacent side. Okay, so I'm going to find the adjacent side, which would be segment BC. So from the angle 49 degrees, we know that the opposite side is 7, and we're looking for the adjacent side in this case. So opposite and adjacent says to use tangent. So write my rule, tangent of theta is equal to the opposite side over the adjacent side. So in this case, I'm going to say the tangent of 49 is equal to the opposite side, 7, over the adjacent side, which let's call that x. Okay. Now, real quick, let me just add this here. The SOHCAHTOA acronym is meant to help you remember what the ratios are, that sine is opposite over adjacent, or opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, but we can also take those things, and since I'm talking about tangent here, I'll go ahead and look at that one. It's also a way of helping us to figure out, well, what do we do when we're solving these things? So tangent is the opposite side over the adjacent side. Now this triangle is a way of helping us to see what are the three ways that we could set up an equation here. So if I look at it from the bottom left corner moving to the top of the pyramid to the bottom right corner, I'm going to say that the tangent of the angle is equal to the opposite side over the adjacent side. Okay. Well, reversing it, starting at the bottom right corner and moving to the top and then to the bottom left corner, I can say the adjacent side is equal to the opposite side divided by the tangent of theta, tangent. And I could also say that if I look at it from the top, I can say that the opposite side is equal to the tangent of my angle multiplied by the adjacent side. Those are the three ways that we can establish or that we can really write to find a missing part of a trig ratio, where I can either solve for an angle or I can solve for a side or something like that. And now in this case, I'm looking for the adjacent side. So what I'm really going to kind of look at is I'm going to look at my ratio like this. So I'm going to say that the adjacent side is equal to the opposite side over the tangent of 49. So you can kind of think of it as these two right here just trade places. We would get the same thing if we did our discrete algebra steps, but we don't need to. So if you type that into your calculator, here you would say that it is approximately 6.085 units long. So for a side, we will round it to 3 decimal places, and for an angle, it's okay to round it to 1 decimal place. Now the last thing that it's telling you to do here, it says use the Pythagorean theorem to find the third side, and we're going to take that and toss it out the window. Because the reason why I'm not going to use the Pythagorean theorem is 2 reasons. One, I have calculated a second side of the right triangle, but what if I made a mistake? What if my answer is wrong? If I use a calculated answer for something else, and my calculated answer is wrong, then my secondary answer is guaranteed to be wrong too. And right now I don't have a way of knowing that I did this correct other than, well, I think I did. Second is because even if I know I did this correctly, I wrote it down as a rounded number. I rounded it. I did not use the exact forever repeating decimal that we had. So because I am using a rounded number, whenever possible, we want to avoid doing both of those things. Whenever possible in mathematics, you want to avoid using a calculated answer to get another answer, and you definitely want to avoid using a rounded number for another calculation whenever possible. Sometimes those things are unavoidable, but we can absolutely work around it. So in this case, instead of using Pythagorean theorem to find the third side, we're still going to use trig. So in this case, we're going to find the hypotenuse. Now I'm going to find AB. So I know the side opposite of the angle was given to me, and we're going to now use that to find the hypotenuse. So opposite and hypotenuse, that says to use sine. So I'm going to say sine of theta is equal to the opposite side over the hypotenuse. Substituting my numbers, I'm going to say sine of 49 to be equal to 7 over, let's say, y. Now, here I can use that same triangle method. We can use it for all 3 ratios, where I say sine is opposite over hypotenuse. Well, this triangle, if I read it left to right, says sine of the angle is equal to the opposite side over the hypotenuse. I could also read it from left to right and say that the hypotenuse is equal to the opposite side over the sine of the angle. And if I read it kind of top to bottom, I can say that the opposite side is equal to the sine of the angle multiplied by the hypotenuse. Now in this case, we're looking for the hypotenuse again, so we're really kind of looking at that same, example that we did a second ago, where I'm really going to just kind of take these two and swap them, and I'm going to say y is equal to 7 over the sine of 49. And when I type that into my calculator, here I would get approximately 9.275 units. Now at this point, what I might want to do, because this is the hypotenuse and this is a leg, I might want to say 9.275 squared minus the 6.085 squared and see, does it give me something very close to 7? And if it does, then I can know beyond a shadow of a doubt that my answers have to be correct. So let's take a look at example 3 here. Let me go back to a brighter color. Okay, sketch the right triangle. So again, we're going to kind of just draw a generic right triangle where we're going to just kind of keep the same things going. We can say this is A, this is B, and this is C. Okay. Now in this case, we don't know any of the measures of the angles. So side A, the 8, has to be opposite of angle A. So 8 goes here. Same thing with C. C has to be opposite of angle C, so 14 is here. So that means 14 is the hypotenuse. Now in this case, because I do know two sides of a right triangle, I will absolutely use the Pythagorean theorem to find the third side. It makes no sense to try to use trigonometry when I don't know an angle to try and figure out the third side of a right triangle. Go back to your tried and true method and solve for the Pythagorean theorem. So here I'm going to say that side B is equal to the square root of c squared minus a squared. Substituting my values, here I'm going to say 14 squared minus 8 squared. And when you simplify all of your numbers, you're going to get 2 radical 33 as your simplified answer. So let me go ahead and probably should have done that in a different color here. Let me go ahead and say 2 radical 33. Now we want to be able to figure out what are the measurements of the missing angles. Now this one here, angle C, that one's easy. That one's 90 degrees. So what are the measurements of the third one, or the second and third one, angle A and angle B? So let's go ahead and find angle A first. I'm going to call this theta. Okay, so from angle A, this would be the opposite side, and this would be the adjacent side. And of course, my hypotenuse. So from angle A, I know the opposite side and I know the hypotenuse. Opposite and hypotenuse says to use sine. So start with my rule. Sine of theta is equal to the opposite side over the hypotenuse. And now let's work it out. Well, if I want to know the angle is going to be the inverse sine of the opposite side over the hypotenuse. So now I can substitute my numbers here. So I'm going to say theta is equal to the inverse sine of 8 over 14. And if you want to do the simplified fraction, you're welcome to. It'll be the same either way. So theta in this case is about 30, oops, can't write very well. Ooh, I didn't realize there we go. Theta is approximately equal to 34.8 degrees. So 34.8. Now, again, at this point, what it's telling you to do is it says use the triangle sum theorem to find a missing angle, which again I'm going to toss out the window for the same reasons that I tossed it out on the last example, because 34.8 is a calculated answer and I had to round it. Now in this case the rounding isn't going to be that very severe, but again, what if I did it wrong? If I did it wrong, the next answer is guaranteed to be wrong also. So I'm going to continue using trig. So let me clean this up here. So let's erase that. And now let's go to a different symbol. Let's say alpha. So here, angle B, we're going to call that alpha. So from here, this would be the side opposite of the angle. This would be the side adjacent to the angle. And of course, the hypotenuse is still the hypotenuse. So from angle B, we have the adjacent side and we have the hypotenuse. So adjacent and hypotenuse tells me I'm going to use cosine of alpha to be equal to the adjacent side over the hypotenuse. Now again, because we are looking for an angle, I'm going to say alpha is equal to the inverse cosine of the adjacent side over the hypotenuse. So now we can substitute. Alpha is equal to the inverse cosine of 8 over 14. So alpha in this case would approximately be equal to 55.2 degrees. And the way I know that at this point, the way that I can check, did I do my trig right for my angles, does angle A and angle B, do they have a sum of 90 degrees? And 34.8 and 55.2 do have a sum of 90 degrees. So we are pretty good with our angles here. So the last thing that we're kind of talking about here is really kind of, this is more of a definition kind of thing. To solve, there's a key word. To solve a right angle means basically to find everything that you can. Basically, anything that you can find, you need to find. Find all of the sides and all of the angles. So the triangle sum theorem simply says that the measurement of angle A plus the measurement of angle B plus the measurement of angle C has to equal 180 degrees. And of course, the Pythagorean theorem would be A squared plus B squared equals C squared, where angle A, angle B, angle C, so this would be A, B, and C the way that I have it drawn. We use a capital letter to represent the angles and a lowercase letter to represent the sides. Now if you notice, there's one more kind of little example right here, and it's hard to see it the way I have it here, so I turned it sideways and I blew it up a little bit. So we're going to do this one here real quick. This is a very typical kind of word problem that we see. It says you're in a hot air balloon 600 feet off the ground, where you can see your friend at an angle from your line of sight of 20 degrees. Okay, so you are in the balloon. So the 20 degrees that they're talking about is right there. And of course this is the 600, and it's hard to see. But there's where your 600 feet is. So we can say 600 feet here. Okay. Now we can recognize a couple of things here, because here we're making our right angle, the 20 degrees, and let me pick another color here. The 20 degrees in the angle interior here has to be 70 degrees because they're complementary. Well, we could very easily kind of extend this out here and say, well, this is 20 degrees also, and this would be 70 degrees. Here's a right angle with 600 feet. And this is just based off of properties of really of a rectangle. Also, and that opposite interior angles are congruent to each other with parallel lines, because this line here and this line here would be parallel to each other. Same thing with the vertical lines here. But it wants to know how far is he from the point directly beneath here. So this is where your friend is, and it wants to know how far would he be away from standing directly underneath the balloon. Now, depending on how you're setting it up, you can figure out, well, do I use the 20-degree angle or do I use the 70-degree angle? So the way that I'm going to kind of look at it is I'm really going to just kind of look at this triangle here that I'm highlighting in red. Okay, and you can use the 20-degree angle or the 70-degree angle from the ground or from the balloon. It doesn't make any difference. Identifying those things in the figure is really the hard part for a problem like this. Usually it's not so much doing the actual trig, it's did you label the things correctly in the figure. So now that we have the things labeled correctly in the figure, I am going to go ahead and use that 20-degree angle here. I'm going to say that that's theta. So here, this is going to be the side opposite of it. This would be the side adjacent to it, and my hypotenuse. So we know the side opposite, and we're looking for the adjacent side. So opposite and adjacent tell me I'm going to use tangent here. So I'm going to say tangent of 20 degrees is equal to the opposite side, which is 600, over the adjacent side, which we don't know. We'll call that x. And just like in the previous example, these two things essentially trade places. So I'm going to say x is equal to 600 divided by the tangent of 20. So our friend is approximately 1,648 0.486 feet away from standing directly underneath the balloon. So these examples here, these are very typical kind of examples that you're going to be seeing when you're working trig problems, whether it's just here's a triangle, solve it, here's an angle, tell me how to figure out what the sides would be, or here's two sides, tell me what the measurements of the angles are. And very typical classic word problem that we see here, and which is really the challenge really to this problem is not so much the trig itself, but did you label the sides and the angles correctly? But those are pretty much it for the examples that I would show you guys in class. And if you have any questions about anything that you saw, by all means, let me know, and I'll be happy to help you out with them. Please make sure you got if the triangle thing with the how you do the angle, how you do the equations threw you off, let me know so we can kind of talk individually about it. But until next time, guys, this is how we're doing our trig stuff. It's really not going to change, sine, cosine, or tangent, depending on what angles you have or what side you have from a given angle. And there we go. Find a missing side or find a missing angle. But thanks for watching, guys, and be good and take care, okay?